time here to present my thesis on the habitat modeling to analyze the impacts of shipping noise on cetaceans along the Irish shelf edge. My aims for this study were to identify the habitat preference for fin whales, blue whales, and sperm whales at the Porcupine Ridge, as well as to quantify the shipping noise levels and investigate its impact on the three species. And the hypotheses linked to the aims are that the spatial, temporal, and the environmental drivers in the region have an effect on the presence of the species, and that the habitat is suitable for the presence of the species. As for the second aim, the shipping noise has an effect on the presence of the species. Moving back to the results. The fin whale models showed significant results with shipping noise, and the odds ratio table showed that with every 1 decibel increase in shipping noise, there was just a 1.73 odds of the fin whale being present when compared it to being absent. And among the different temporal variables, with every night, there's a 1.65 odds of the fin whales being present higher when compared to months, days, and during the daytime. But with every 1 milligram per meter cube increase in chlorophyll concentration, the odds of fin whale being present were 22.69, which is quite high when compared to the other two results. And this graph shows the fin whale detections against the shipping vessel detections, with shipping vessel detections in yellow, and in purple are the fin whale detections. And you can see the peaks of fin whale during April, and they decrease over the summer months from May to June because they're not present they're not vocalizing during the summer months. And for blue whale model, it showed that with every 1 decibel increase in shipping noise, there was just a 1.12 odds of detecting a blue whale. But blue whale showed no significance with any of the habitat drivers. And a similar graph for this model as well shows that over the study period, there were really low number of blue whale detections when compared to the shipping noise. And the low number of detections is mainly because the blue whales are not present in the region during the summer months. Moving on to the sperm whale model. The sperm whale model showed significance with shipping noise, where with every 1 decibel increase in shipping noise in the region showed just a 1.10 odds of detecting a sperm whale. And with every 1 meter increase in sea surface height, there was just a 1.93 odds of detecting a sperm whale. But with every 1 meter per second increase in current, there was a huge chance of detecting a sperm whale. And a similar graph to show the distribution of detections over the period of time shows that the sperm whales also had low detections during the study period. So moving on to the discussion as to why we see the results that we saw. The fin whales are present in the region. Due to the high upwelling and downwelling, there's a high nutrient inflow in the region. And in the presence of high chlorophyll concentration, it leads to a higher productivity, which means the presence of higher availability of prey, which is the northern krill for the fin whales. And this is seen in several studies. And also the higher detection of fin whales during night when compared to the other temporal variables could be due to the diurnal vertical migration of krill, as seen in other studies as well. Moving on to the habitat suitability for blue whales. The blue whales are not present during the study period, which was in the summer, but therefore, no significance was found with any of the habitat drivers. But previous studies show that blue whales also prefer productive shelf break regions with high upwelling and downwelling, which again leads to a higher abundance of krill, which is also their preferential prey, as fin whales and blue whales are baleen whales that prefer euphoseed species. And several studies also show a niche overlap between fin whales and blue whales as predicted in the study. But careful interpretation is required for the results due to the really small sample size of blue whales. Moving on to the sperm whale detection, the sperm whales are said to peak during summer months, which we do see during May, but it decreases over time. And the detections are overall very low during the study period. And several studies show that canyons are hotspots for sperm whales due to the presence of a high prey availability, which are cephalopods and fishes. And this is due to due to the presence of oceanic fronts in the regions of the canyon. But again, careful interpretation is needed due to the low number of detections. So moving on to the effects of shipping noise. So behavioral modifications seen in other studies for fin whales show that the fin whales change their temporal and spectral features of their song notes while communicating. And they also react to noise that was as far as 2 kilometers, which shows that they're hypersensitive to the acoustic changes in acoustic ambient noise. Would shift to high frequency range and decrease their number of calls in presence of shipping noise. And similarly, humpback whales showed a much higher call repetition in the presence of shipping noise to overcome masking. And behavioral modifications observed in blue whales show that there was a lower tendency to initiate foraging in the presence of high ambient noise. And also, several studies show that in the presence of shipping noise, their communication is highly fragmented and reduced, maybe up to 67% as well, seen in a study in right whales. And they also showed reduced vocalizations during mid-frequency sonars testings, which is beyond their frequency range, which is quite interesting. Shipping noise effects on sperm whales, as seen in previous studies, show that sperm whales changed their diving and breathing rhythms, as well as had shorter time intervals between their blows. And they also seem to stop feeding in the presence of shipping noise and reduce their communication up to 32%, and also show signs of moving away from the region. And such behaviors were also observed in other odontocetes, such as killer whales and dolphins. Overall, the implications of shipping noise were that due to this and behavioral compensation, energy consumptions increases, which would lead to a reduced time investment in biological functions. It would disrupt breathing, disorientation while navigating, and also reduce foraging capabilities. And if this continues, a predicted increase in population vulnerability would be seen, and long-term exposure to such shipping noise would either lead to the displacement or abandonment of suitable habitats, which is really detrimental for the survival of the species. And to conclude our hypothesis, the region was said to be an important habitat for fin whales, but also studies show that it could be a possibly important habitat for sperm whales and blue whales as well. And according to our second hypothesis, we also saw that the shipping noise does have an effect on reduction of whale detections in the region. For more robust results, you would need long-term monitoring in the region. And it's also imperative to declare these habitats as critical habitats even for migratory species. And this study would provides baseline information to implement effective conservation measures. Overall, the limitations of the study were that the false absent detections in the dataset were not accounted for, that if the whale was just masked, but was still present in the region, or was still present in the region and not vocalizing. And the period of study was really short to make robust conclusions, as well as the data was limited to just one location along the shelf edge. And type 2 of the three models, where the models predicted the absence of the data better than the presence due to the high number of zeros in the data, which is the absence data. Therefore, I would recommend to have like a long-term study over a year to have even temporal variations included, and include a larger study area with a larger sample size to have more robust results. And include automatic identification system information of vessels to complement the vessel detections in the region. and also to have dedicated as well as opportunistic visual monitoring in the region to information to the dataset, and the use of novel developing techniques to have better model predictions. And I would like to thank my supervisor, Joanne, the IMBRSea, Dr. Ian, and my friends and family for all the support during the thesis. Thank you for your attention. Questions?
Thank you very much, Kavya, for